Once again, welcome to all. Okay, so some kinematics and theory of mathematics. Okay, after the last class, if you have any question, you can ask. Otherwise, after that we'll be going ahead to going ahead with the new topics. Okay. So what we have discussed in the last class, do you remember? So anyone who recall the thing what we have discussed in the last class?
To find out, sir, whether a diag- classification diagram are kinematic chain or not. Link pairs.
Okay. Okay. Thank you. So those are the things we have discussed, right? So, okay, we have had two equation for finding out for a lower pair mechanism whether that particular a chain with lower pair, okay, whether it is constituting a kinematic chain or not, this particular linkage. So those things we have discussed. Then we have studied about the inversion of mechanism, what to understand by inversion of mechanism. Then we have said that basically four bar chain, slider crank chain, and double slider crank chain. Those are the main three types of kinematic chains which we will be discussing, and the inversion of them we are going to discuss. Okay, so later on we have also discussed how to find out what kind of joint is this, okay, whether binary, ternary, quaternary, etc., and how like the if kind of n number of links are connected at the joint. Then we have also seen that basically it is equivalent to n minus one binary link. Okay, that means ternary joint. Okay, it's kind of equivalent to two binary joint. Quaternary joints, so 4 minus 1 equivalent to 3. Okay, then we have also discussed about the different types of constant motion, and that we have studied about completely constant motion, incompletely constant motion, and successfully constant motion. Okay, so today we are going to discuss about like the mobility of mechanism like Grashof's law, and what type of under which category of mechanism it falls. Okay, with so those kind of things, class one mechanism, class two mechanism, what kind. So those are the things we are going to study now. So prior to that, just one concept regarding plane and space or spatial mechanism. Okay, what we understand by that, that we'll just understand. So basically, in our course, we'll be mostly dealing with the while analyzing purpose. Okay, mostly we'll be dealing with the planar mechanism. So plane or planar mechanism, it's just that basically what happens. Let's consider this particular one. Okay, so the left hand side mechanism, it's a kind of four bar mechanism. Okay, so now here how we can be sure that it's basically four bar mechanism or four links are there. So you see, so here this is a ground or fixed link. Okay, similarly this is the right hand side wherever hatching mark is there, that is the ground or fixed link. So that is one link. This left hand side, this o to another link, a b another link, b o for another link. So fixed link and these three links, that is four links. So now whenever this kind of situation arises, that all the points on the mechanism basically they are moving on the parallel plane. Let's consider, if you consider any point on this link or maybe another point here on this link or maybe on the other link. Okay, whenever it is having relative motion between them, so it will be something like they are moving in parallel planes. But now, if you think of the right hand side mechanism, that is nothing but an example of Hooke's chain. Actually, we'll be later on discussing in details. Now, here you can see it with respect to this coordinate axis x, y, z axis we are showing. So now here the mechanism links itself are not in certain parallel planes. Okay, they are oriented in different orientation in the space, and that's why here the points on this mechanism, if you consider, if this is one axis, this is another axis, this way another axis, if you consider, so they are not going to move in parallel plane. So that kind of mechanism is known as space mechanism or spatial mechanism. Now mostly we'll be dealing with, in our situation we'll be mostly dealing with planar mechanism, where the movement of the different link is in different, you can say, like parallel planes. Okay, understood? So already we have discussed about those higher kinematic pair, lower kinematic pair, depending on the type of person. And here I am just showing you like different assemblies. Okay, it may be kinematic chain, whatever we have discussed. It may be kind of open kinematic chain, uh, just like the right hand side one. Okay, or it may be closed one. So right now you might be wondering why I am saying left hand side one is also a closed one. So now here this hex mark, whatever is there, okay, ground links I am showing. So they are nothing but kind of fixed or ground links. Okay, and now they we can draw, I can show either these points as fixed, okay, or I can also draw something like this. Let's consider the previous one. Okay, let's consider we have got multiple join. Okay, here and this and it's not a good diagram right now. Okay, so now how many links do you think is are there here in this particular diagram? How many links? This is what kind of position? These are fixed position, right? All of you are with me?
Yes, sir.
Yes,
Okay.
sir.
So now here this is how can I number them? Always I am saying the fixed positions. We'll name it the same number. Suppose let's consider one first link. Okay. Now this is second link. This is third link. Similarly, this is fourth link. So fourth link. Now the same thing. Is it a closed or a open one? Who can tell me? This basically is closed. How? Actually, I can draw is if these two situations are drawn. If I draw like this, or if I draw something like this, the same thing. Okay, if I draw something like this, and if I show the whole link as grounded, okay, so it is having the equivalent meaning, same meaning. Okay, so that is the thing. Okay, they are understood. Similar is the case here. Okay, so here in the left hand side, these are grounded. So I can either draw like this, or I can draw the whole link and show the whole link as grounded. Or this one I can show. Similarly, this one basically it's a skeleton for nowadays whatever industrial robot that you see now, it is based on this kind of open kinematic scene. Okay, so close means ultimately first and last. Okay, they are connected. Okay, well fixed, and open means ultimately one end. You can say it's a basically open. Okay, so that is basically about close and open kinematic mechanism. Now, already I have said that basically in practice, in real life, the different links they may look different. Okay, they will have certain different look, but for ease of understanding, for ease of drawing, etc., what we do, we in a simple manner we try to show them. Okay, so here you can see that kind of list, one list has been made. So here the kinematic representation for the actual typical frame or link forms has been shown. Okay, the first one you can say it's a kind of simple binary link. So in actual sense it may look like this. Okay, so but we'll be drawing in our case for making it simple like this. Okay, similar is the case here. It may be kind of another simple link, but which point for point of interest. Okay, so here it's kind of somewhat pen. So this kind of link we can draw like this. Here you can see that basically of one and two, these two ends only, at these two ends only we can join to some other links. But here it is a kind of certain form is there, and this particular form is also important. That's why we are showing like this, and this whole thing has been patched. So this is a single link. But you can see here in this portion, we are not showing any this kind of joint. Actually there is no joint here, but this is the form of it. So it is a simple binary link only. Okay, but this shows that actually it has got something, some other point of interest apart from only having a single line kind of configuration. So we can have some other complex link where 1, 2, and 3 points we have got 3 joints where I can join. So in those cases we'll be showing like this. The whole thing is hatch. Okay. Similarly, pin join, two links are joined with a held with a pin or hinge, so that we show like this: first link, second link, and this is the join. Okay, in actual sense it may look somewhat like this, but we'll be drawing like this in simple case. Similarly, slider join I can show like this. That means the one surface on which it is going to, this block is going to slide, so that way we represent the slider join. So automatically you must understand that this is the this situation may represent any kind of actual in real life. It may look somewhat like this. Okay, similarly, cam pair or cam join icon, we simply show like this in kinematic representation. Similarly, gears, we just show it this. Okay, we don't go for making it complex by showing all the teeth, etc. Okay, so similarly here you can see some of the as an example of close kinematic chain. So this can be one. So here I have already told that I can either draw, we can either draw like the whole bar. Okay, and you can show whole thing as fixed, or I can show this point of interest, okay, this point as the ground link. So that will also mean ultimately the whole thing, this and this if I join, or this and this if I join, it is the same thing. Okay, understood? So this and this if I join, and similarly this and this if I join, they're having the, and if I draw like this everywhere, if I show it, okay, then okay, if I draw something like this, it is having the same meaning. Understood? Similar is the case there, we are showing one 5 per linkage here, this case. Okay, so what kind of joint are they? What is the type of joint? Who can tell me? Who can tell me the type of joint here? These are pin or hinge joint. Okay, so they are different. Here the slider crank we are showing. Okay, so here one guide will be there. Okay, because of the guide only, the slider will be able to slide like this. Okay, and the crank will, understood? Similarly, one open kinetics that we are showing, okay, and here you can say we have got the ground or base link, okay, and there may be, depending on what is the actual configuration, we can have different link, one link, and the joint we have different link, joint, and this being linked here, okay, like that. Sorry. And this is the actual example of that. Okay, that means whatever actually nowadays you see the different types of industrial robots that you see, it is based on this. Okay, so we have got the ground here. Okay, we have got this pass base link here. Then depending on what type of movement you have to give, different actuators will be there, and those links will be given different motion by an actuator. Then we'll have the end effector here, right? Okay. Up to this much, any confusion, anyone? All of you have understood the things? Let me know.
Yes.
Okay, thank you. Okay. So next thing that we are going to discuss is about planar forward mechanism. So by the word planar, we mean that basically they are the different links which are there on the different points. If we consider from different links from that particular mechanism, they are going to move in parallel. That means you can consider one point here, you may consider another point here, maybe another point here. Whenever this kind of motion it is there due to the type of joint, what kind of pair it is constituting based on the type of relative motion? Revolute pair, turning pair, or revolute or turning pair, or sliding pair, what kind of pair? This pin joint or hinge joint, what kind of pair it is constituting? Because of this pin or hinge. So it gives rise to revolute or turning kind of pair. Okay, so now this particular forward mechanism, already also we have also previously also discussed. So this is the most basic of all the mechanism and kind of forward mechanism. Already we have check also whether this kind of assemblage is going to give you certain kinematic chain or not. Now that assembly was giving us kinematic chain. Now if we fix, that means this portion actually here this green portion are fixed. So one link from that particular kinematic chain, whenever we have fixed, so it gives rise to a particular mechanism. And now from the forward chain, whatever mechanism we are getting, that is nothing but forward mechanism. Okay, so now from the name itself, all of we can very easily say it is actually comprising of how many links? 4 links. Okay, considering the ground link, it has got 4 links. Okay, and ultimately if you already we have done the analysis, we get 4 kinematic pairs out of it. So we can give this as number 1, this link number 2, number 3rd link, number 4th link, and once again this is nothing but number 1. Yes, because this is the same ground link. Okay, so generally this joint portion, okay, this joint or this, if you consider, these are nothing but pin or hinge joint that we have. So because of that, they can have relative motion between them, and what type of relative motion they can turn. Okay, they can revolve with respect to each other depending on what is the whether they'll just oscillate or completely revolution. They will have, that will depend on the different aspects like the link length, etc. Okay, different, but they can have turning motion with respect to each other. Okay, so they are considering revolute or turning pairs. Okay, And basically, like planar forward mechanisms are the simplest closed things. Like the crank rocker mechanism, we have different slider crank mechanism, etc. They also falls under that. Okay. So up to this, any confusion if you have, if you let, you can let me let me know. Any confusion, any question if you have. So if no, we'll move ahead. Okay. So now we know that basically forward is most fundamental of different plane kinematics, and also we sometimes call it a kind of quadric cycle chain because these links are also there. So from there the word quadric. Okay. So now generally forms kind of looks like somewhat quadrilateral, okay, having four pin joints, so quadric cycles in that one. Okay, so as we have discussed, so because of the pin or hinge joint we have got turning pairs, okay, four turning pairs. And what happens if we think of the four bar chain? So from a kinematic chain, if we fix one link, let's consider this link we are fixing. Okay, so we get what? Kinematic. From the kinematic chain we get a mechanism, and based on whatever is the parent kinematic chain, that is the four bar chain, we get four bar mechanism. Now in general what happens, the link which can make complete revolution we generally call it as crank. Okay, and the rocker is the link basically which can rock about a particular point. That means it will not have to like kind of oscillation kind of motion, but it will not make the complete revolution. And connecting rod or coupler, this is the generally is the link which is opposite to the fixed link. Okay, so that is known as the connecting rod or also known as coupler. Okay, so the link which can make complete revolution is crank, which the link which is opposite to the fixed link, that means this. Okay, this link that is opposite to the fixed link is the coupler. Okay, and depending on what kind of movement we have got on the fourth link, so you'll call it as lever or a rocker if it is going to oscillate, or depending on the on that particular type of mechanism, if it is due to the you can say structure of that particular mechanism, if the fourth link can also make a complete revolution, then once again we can call that as crank also. Okay, so if it makes complete rotation, then crank. If it is just oscillating kind of percentage haircut, we call it as rocker. Okay, any confusion up to this first? I hope it's clear. Now there is a very interesting kind of law known as the Grashof law, Grashof apostrophe Grashof's law. Okay, from which basically gives us some indication about the type of movement or that you can expect on that particular link, and how it is related to the, you can say, the link lengths. Okay, and how from a in the from like a forward mechanism, a planar forward mechanism, how the link length is actually giving rise to different types of mechanism, and when we get class 1 mechanism, when we get class 2 mechanism, or what kind of different mechanism it's possible, like crank rocker, etc. When it is going to behave like that, there is a simple law known as Grashof law. Okay, so now according to this law, if you consider uh, like the planar forward mechanism, a planar forward mechanism, let's consider a planar forward mechanism. Okay, so we have got these are the joints. Okay, pin joints, M joint, and if it has to be mechanism, one link has to be fixed link we show like this. Now let's consider this is the length, longest links. Okay, so length is L. Okay, and let's consider this is the shortest link we are denoting with length S. Okay, and these two are another two link, and let's consider the link like this P, or one maybe it's Q. Okay, now if L and S, they are nothing but the length of the largest and the shortest link from a planar mechanism, and P and Q are the other two link. Okay, now if this situation is happening, that means L plus S, that's length. Okay, that is less than equal to the addition of the lengths of the other two links. Okay, then this kind of forward mechanism will have at least one revolute ring in them. Okay, so that means one complete revolute, that means one crank will get out of it. Okay, and if that means this particular law is being satisfied, L plus S, these are nothing but the link lengths. Okay, L plus S, it is less than equal to the length of the addition of length of the other two links. Okay, that is P plus Q. Okay, if it is being satisfied, okay, then it's also known as, this kind of linkage is known as Grashof linkage. And whenever they are satisfying this class of links are also known as class 1 mechanism. And if it is not satisfying the equation, it will it will be known as class 2 mechanism, and it is going to form a rocker mechanism. Okay, so that means this particular link length indication, it gives rise to this particular situation. That means if this is happening, L plus S is less than equal to P plus Q, that forward mechanism will have at least one revolute link in them. Okay, that means one link, at least one of the link will behave like a kind of crank. Complete revolution will have, otherwise no. Okay, now based on that, this particular equation, we have got inversion of Grashof links. Okay, now what happens, we know that there are four links here. Longest link is denoted by the length L, shortest by S, other two are P and Q. Okay, now let's consider we have now from that particular planar forward linkage, we have to fix at least one link. If we fix one link, then only we get that particular mechanism. Okay, now let's consider the shortest link, that is S, we are fixing. Then what we'll get, we'll just get a mechanism which is double crank mechanism. If the shortest link is behaving like the coupler means what we have already drawn. So the link opposite to the fixed link is known as coupler. Let's consider this kind of situation. Shortest link is, this is the shortest link. It is behaving like the coupler, right? Coupler means the link opposite to the fixed link. This is the fixed link here. This is the fixed link here. This is fixed, right? And this is opposite to it. Okay, so and it is, let's consider shortest link is behaving like coupler. Then we are going to get double rocker mechanism. That means two of the links is going to rock only. Okay, and when shortest link is crank and any of the adjacent link to shortest link is fixed, we get crank rocker mechanism. And if that particular situation is not happening, that means it is not satisfying the Grashof equation. Okay, then we get rocker mechanism. So these are the four types of inversion of Grashof linkage. Based on how we will be able to obtain, we'll just have to check like what is happening, whether L plus S is less than or equal to P plus Q, or it is satisfied or not. Then and based on that, whether class 1 or class 2 will get. And apart from that, depending on whether shortest link is fixed, whether shortest link is behaving like coupler, or what kind of thing is happening, based on that we are going to get double crank mechanism or double rocker mechanism, etc., etc. Okay, understood? Let me know.
Yes, sir.
Okay, any confusion after this one?
Sir,
Yes,
sir, can we get the PDFs of this?
yes, definitely will get, don't worry. But in the meantime, the important things, you can let's note down the important things, and whatever responsible problems we are solving, try to solve along with me. Okay, I'll be sharing this PDF also. Don't worry. So now there is one very important angle known as the transmission angle, and from the name itself, you can very easily understand that this angle is somehow related to the motion transmission. Okay, and now what is this transmission angle? If we consider, suppose once again, this particular figure, okay, which is showing a planar forward mechanism. Okay, now it will have some input link. Okay, that means where we have to give the motion. Okay, and then only because of the whatever is the structure, whatever is the type of joint which different motion it is allowing, etc., etc., based on that the motion will be transferred from the input to the output link. Let's consider this is the input link. Okay, and we have got this particular coupler here, okay, which is joining this and this, and we have got the, we are getting the output motion here. Okay, and this is fixed. Okay, now what is this transmission angle? Now this transmission angle, okay, it is the angle generally denoted by mu. It is the angle between the output link and the coupler. So this is the output link here, okay, this link, and we have got the coupler here. So right now whatever angle they are making, that is nothing but the transmission angle. Okay, so now for a particular value of force that is there in the this particular value of force that is there in the coupled rod. Okay, so now the torque transmitted to the output link, that is the output link, torque transmitted to the output link about this point D, about the point D is maximum when this angle mu is 90 degree. Okay, so when it is angle is making 90 degree, torque transmission to this angle is to this output link is maximum. And why we are dealing with torque, because we are talking about this rotational kind of motion that is there. And now this is the input, so maximum torque when we can get when transmission angle is 90 degree. And now if we consider BC and CD, that means this BC and CD, these two link, if somehow they are making they are being coincident means they are kind of overlapping. So if they overlap BC and CD, let's consider this is decreasing, angle is decreasing and they are overlapping, that means transmission angle mu is 0, and in this kind of situation the whole system will jam or lock, there will not be any motion possible. Okay, so but the thing is, this is the extreme case, 90 degree is the best possible thing, 0 degree it will jam. But in actual sense what happens, so we know that these are kind of physical things, so it has got some masses involved, ultimately some inertia, and now to give some motion we have to act against inertia. Yes, so we have to apply certain minimum value of force or torque so as to give it this particular required motion. Okay, so now in that case mu, if it is deviating significantly from 90 degree, then actually the torque that we get on the output link, it is going to decrease. Okay, and sometimes the mechanism may jump, because whatever is the available torque that is there, it is insufficient, it is not sufficient to overcome the friction of the system as well as the inertia of that particular system. Hence mu generally we keep more than 45 degree, then at least we can be sure that actually it is going to have that required motion. Because otherwise if you make certain mechanism and the link itself, even if you apply certain force, it is not going to respond, okay, then it's of no use. Okay, the design is a failure, so you have to take care of this kind of thing. Okay, so that is why transmission angle is important. So after that, just by using cosine law, we can find out like the requirement of the transmission angle. Just you can just go through it. What happens when mu is maximum, when mu is maximum, when mu is minimum, whatever is the thing we have just said. Here is the small derivation that is there. Just by using from cosine law in two, we are making two triangles out of that by drawing this particular line. Okay, so and we are applying cosine law to this triangle and this triangle. Okay, and just simplification. Okay, so this much you have understood, all of you have understood. Class 1 mechanism, class 2 mechanism, etc.
Yes.
Okay, so now we can just check by using small small problem we can just solve, or maybe this problem we'll solve in the next class. For today you remember those things. Okay, what is class 1 mechanism, class 2 mechanism, what is Grashof law. Okay, when it is satisfied, okay, what will happen if Grashof law is not satisfied. Okay, what are the different inversions of it. Okay, what is planar mechanism, special mechanism, etc. So those things you understand. Okay, so and be thorough with whatever when we are going to get, suppose what kind of mechanism, rocker, crank rocker, etc., or double crank mechanism. So in the next class we'll try to solve some problem. Okay, so with this then we'll stop for today. I'll be taking the attendance, so be responsible, and if you have any question you can ask. Up to this much you have understood, right?
Yes.
These are interesting things. If you
Yes.
just, okay, so respond to your name calls. Nilutpal. Nilutpal. Absent.
Absent.
Shankar. Shankar.
Yes, sir. Yes, sir.
Arshisman.
Yes, sir.
Rehan.
Present, sir.
Partha.
Present, sir.
Rishikesh Basumatari.
Present, sir.
Hermiki.
Present, sir.
Here, Mickey. Okay.
Present,
Mahasal.
sir.
Yes, sir.
Defend Mahasal.
Yes, sir.
Teza. 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 Absent. Rishikesh Nath.
Yes, sir.
And Emil. Emil. Absent. Okay, so we'll stop here for today. So thank you everyone for joining. So go through the things properly. Okay.
Yes, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.
Present, sir.